First presenter here is Wilma du Plooy, and Wilma is Program Coordinator of Post-Harvest Disease Research. She's very well known to everybody, and she will talk to us on chlorine management in the packhouse. Thank you, Wilma.
Thank you, Hannes. Thank you, Hannes. You're also from a very hot and humid Nelspruit. I appreciate you guys being here today and your attendance. I hope that you can organize yourselves a happy hour at the end of today. And it's going to be my pleasure to talk to you about a somewhat contentious topic today has been viewed with increasing suspicion. And I think it's time for us to get the facts straight of what's going on. So the talk has very simple structure. We will be reviewing some of the needs for chlorination and then some of the actions that you guys need to take or avoid, things that you need to remember, and a refresher on the optimal parameters then for chlorine application. Okay, so I want to kick off my session with a question to you. Do you still use chlorine in the packhouse? And then maybe just some of your concerns there with what you do. And whilst you are mulling about that, I would like to then talk about the sources of wash water that we typically use in packhouses, which would be surface water, groundwater, and municipal water mainly. And then it could be a combination of surface water and groundwater. And the chlorination of these water types are usually of big concern to us, not so much municipal water, or that's what we would think, but it's especially surface water that is of high concern to us with the variable quality and then the high risks regarding microbial loads and even chemical loads when we look at runoff from agricultural activities. So in terms of why we chlorinate, then the purpose, and we've spoken a lot about this at previous workshops, is to achieve disinfection. We want to inactivate the microorganisms that may affect our fruit. And so
Wilma, your mic is off.
Wilma, while she sorts out her mic quickly. It seems Wilma's lost the connection. We'll just give her a moment quickly. Okay, there she's back. She'll join us just now.
So chlorine has not been banned. It's something that you guys really need to pay attention at. It's fake news. And then the issue with chlorine is actually the chlorites. Now the chlorites can be easily managed to within the European limit of 0.05 parts per million. And then I want to point out that to date in our industry, we have not exceeded any MRL for chloride. So this is important going forward. Then the second question that I want to put to you guys today is, do you know that swimming pool products are not suitable for use in our fruit packhouse? And I want to just maybe assess your experiences around that. So on that poll, moving on whilst you are busy thinking about it, the reasons we don't use chlorine from swimming pool products is that these products contain additives. And these additives are there for the benefit of the pool, not for the benefit of us in the packhouse. Stabilizing agents, salts, colorants, things like that, it can adversely affect our fruit, and it can also contribute to unwanted residue. So it's really important that we look at that, but also you spend a lot of money on that product and then you don't get efficient loading of the active that you are looking for from those pool products. which is why we don't use them. What we then should be using is chlorine from more pure sources. Now, chlorine is on its own a very powerful disinfectant with good oxidizing properties. The disinfection that we get from chlorine comes from two sources when the chlorine dissociates, and we're going to talk about this again so that these words become more familiar to you. And then also in our industry, we want to see this come from calcium hypochlorite, which is a solid, and we have seen people using sodium hypochlorite and chlorine dioxide. Now, the terms like free chlorine, reactive chlorine, and then available chlorine, these all refer to the chlorine that is in some or other form ready for oxidative reaction in our washing solution. Now, what you should be doing is you should be using calcium hypochlorite. I've given you some molecular formulas there for those of you guys that are interested and want to study the labels. But calcium hypochlorite usually comes as a powder formulation, which makes it very stable and very easy to handle. This powder formulation then gives us more than 65% available chlorine. And the fact that it can be stored as a solid means that there's much lower decomposition of the product. And this decomposition is usually then 2 chlorites, which is undesirable. And this is in comparison then to our liquid counterparts. Sodium hypochlorite, on the other hand, is usually a liquid, and it's very well known to us as laundry bleach. So it should never be used in our packhouse. The sodium hypo usually only comes as a fresh solution. It comes with a 10 to 12% active concentration. It's already low. Then it deteriorates quite rapidly so that we end up with way too little active for any disinfection process in our baths. And then, very importantly, the degradation of sodium hypochlorite results in very high levels of chlorites and salt, which is not desirable at all. So what happens with sodium hypochlorite? And just to make it a little bit more clear, I've been using the word species, so I thought let's use little fish. Hypochlorous acid and hypochlorite as ions are the two chemical species in our calcium hypochlorite solution. And before we move on, I also want to point out this solution needs to be prepared before you put it into your bath. So when you're topping up, do dissolve it in a little bit of lukewarm water before you add it to your packline water. That ensures that these two species will be present and that you will get the active action that you need. Then looking at what happens in our solution at our neutral pH, or even pH 7.5, we find that hypochlorous acid and hypochlorite ions are in equilibrium. In other words, they're present in equal numbers. Now, if you look at our recommendations through the years, we always say drop the pH a little bit. And there's a very important reason for that, because when we drop the pH a little bit, we find that the hypochlorous acid overtakes our hypochlorite ions. And this results in better disinfection. Because remember, as I've said, it is our hypochlorous acid, which is the strongest sanitizer and which does the cleaning action in your solution. And that is why this is the one that you want to be in abundance. The other one can be in lower concentration. Okay, so my question at this stage then is, have you paid attention now? Do you understand why this is important then for us to use a specific chlorine? And I would like to know your feelings on that. Okay, and whilst we're busy with pH and all of that, I would also like to clear the air on something else. pH only comes in a range from 0 to 14. I've given you a little diagram there. You can look at it afterwards on your presentation again. This is really important to note because there's been a lot of fake news about the pH range. pH exists from 0 to 14 because it's a logarithmic measurement of the hydroxide ions in a solution. This cannot exist physically or chemically beyond those two values. So these WhatsApp messages that tells you to eat something with a pH of 22, hashtag fake news. So you need to remember then what is our optimal pHs and that we want the hypochlorous acid to be the abundant species and what the ideal pH range for that would be. And then you also need to know that chloride formation, which is what we don't want to happen, is a function of the pH, the presence of free metals in your solution, and then also the hypochlorite ion concentration. Then we also want you to look at ORP. And then what is this ORP thing anyway? So ORP is an acronym for oxidation reduction potential. And this is something we many important chemical reactions, whether you're a living being or whether you're an analytical reaction in a vessel somewhere, you have this sort of thing happening. And this is where we have oxidation and reduction of active chemical species. Our calcium hypochlorite dissociates, there's that word again, remember I spoke about it earlier, and it gives us then the hypochlorous acid and the hypochlorite, and this dissociation depends on the oxidation reduction potential of our solution, the ORP. ORP does not measure your water quality. It will not tell you the microbial load and the TDS and things like that. It only tells us what the potential of that solution is to have a successful oxidation or reduction activity take place. Okay. So to get the best activity, I've given you a summary. I'm not going to go through it. You guys can go through it again, but there it is nicely summarized for you for future reference. And then the take-home message for today is chlorine has not been banned, and that we have never exceeded the chloride MOL, that we need to manage our pH and our ORP to get optimal product performance, and that I want you to remember, please, chlorine is still an effective sanitizer, and it is still internationally widely used in all fresh produce industries. And with that, thank you very much for your attention.